Good day. This is nutritional advisor Sean Balderas. Today I'm going to be explaining to my client, Jessica Krisky, the causes, concerns, solutions, and the science behind celiac disease. So first, celiac disease is an autoimmune disorder that prevents a person from being able to eat any food that has gluten, which is a certain protein. If you eat gluten, depending on the personal, depending on the severity a person may have, which is not definite from an outside um, perspective, you can have different reactions if you eat gluten. Like, I have celiac disease, and my mom has it. My mom has more severe reactions though. She may get a rash or throw up or something, but I would just get like a bad stomach ache for a day or two. So that brings it to the topic of how you get it, which is either by eating gluten a lot in your lifetime, you can just contract it randomly, or if you had a family member, like a grandparent or a parent who has had it, you can develop it just from having it in your genes from them. And even though that is a 1 in 22 chance of getting it from a relative, according to the Chicago Celiac Disease Center, it is still possible. So, as I said, reactions are different from person to person, but they can be bad or really bad. That's about it. But yeah, unfortunately, I don't think there's any way that there's been no known cure ever to celiac. So if you have it, you probably have it for life. So that brings us to our next topic of meals you can have. So for breakfast, you could have 2 eggs and gluten-free toast. That's an average breakfast for me. I think so. Lunch, you could have a peanut butter and jelly sandwich, like 2 oranges, some carrots. I mean, seems like an average lunch, but I mean, it works. For dinner, you could have grilled chicken, mashed potatoes, asparagus, standard dinner that is nutritious for protein, grains, and vegetables. So that's good. But for the bread, for what I said for the toast for your breakfast, and bread for peanut butter and jelly, make sure to get select gluten-free brands like Udis, I think that's how you pronounce it. It's UDIS. Like that's a big brand for it. They're good. Glutino, like GLUTINO. That's a fine brand for that. So you could use those types of bread. They have breads among other types of foods that are selectively gluten-free. And for snacks, you could have nuts, most potato chips, unless they have unless they were baked in oil that gluten stuff was. Those two are normally good. Like select cereals, not all cereals are. I know Cheerios, they're fine. Fruity Pebbles, Cocoa Pebbles, those are all fine. But then there's some like Reese's Puffs that, though they are really good, they have gluten. So those are just some meals you could have if you have celiac. So our next topic is the structure of the 4 macromolecules, which are carbohydrates, lipids, proteins, and nucleic acids. So carbohydrates are normally hexagonal chains of carbon, hydrogen, and oxygen that can be monomers or polymers. All of these can really be monomers or polymers. On the left one on that image, you can see that it is a chain of them, but if you look at the atomic structure, if you zoom in even more, you can see that it is a hexagon shaped chain of combinations of those elements. So for lipids, it is just branch chains of the same elements, carbon, hydrogen, and oxygen. So they normally have a line with branches coming out of them, long strands of those branches. That's about it. Proteins are normally single file chains of amino acids bonded by, and all those amino acids are bonded by peptide bonds, which are just specific bonds, like chemical bonds for amino acids to make proteins. Because if they didn't have them, they wouldn't be proteins. They'd just be single amino acids. Nucleic acids, they're either they're nucleotides that bond together to form DNA or RNA, and I'll get more to that later of the functions of those. So the function of the 4 macromolecules. The carbohydrate are generally for long-term and quick energy and structure. So complex carbohydrates, stuff like starches like bread and crackers and stuff, and like quick are in like it's in a lot of candies and stuff, just like random snacks, stuff that aren't like really just a lot of stuff that aren't supposed to fill you, but like have some starch in them, like candy and potato chips and all that, like tortillas, stuff like that. Lipids are just like for forming cell membranes. They're for storing energy. They insulate your organs, and they signal molecules and hormones inside your body. Proteins are for structuring your body. They store energy for your body to use later on. They carry out cell metabolism, and they form antibodies which help you fight off diseases. Nucleic acids are the blueprints for life, so DNA, RNA, they carry genetic code inside them. So DNA is really just like kind of determines your identity and stuff. It's all the DNA inside the nucleus of a cell. But the RNA is like, if you scratch your skin or something and you see the scratch marks and then eventually heals, that's because the DNA died where you scratched it, and then RNA came, specifically messenger RNA came in, and it replaced that DNA, because messenger RNA is usually like a half strand, DNA is double strand, as you probably learned before. So in those DNA, RNA, and nucleotides that make them up, which I'll get to in a second, those create proteins. So the monomers are the four macromolecules. For a carbohydrate, it's monosaccharides, which are those, as I said earlier, those hexagon-shaped things of carbon, hydrogen, and oxygen combinations. For lipids, it's like glycerol, which are, as I also said, you can see the branched formation of those atoms. You can see how like it's like a line, and then they branch out at different the different parts of the like molecule. Proteins are amino acids, and in that atomic view, it looks really weird. But when you look at it a little farther out on a molecular view, amino acids look like spherical and stuff, and they're more uniform. Nucleic acids are nucleotides. It's a sugar, phosphate, and base, and they all connect to make DNA and RNA. The four bases are adenine, thymine, cytosine, and guanine, which you probably learned before also. So that's about it. Yeah, that's about it.